Hello, viewers. In this episode, we will be taking some common problems and asking how does that happen? Some normal problems and some explaining like why do we do this? We all have that in our daily lives, and of course, we will be also putting a scale to size, which I'll link or show later in this video. So, without further ado, let's get started. Hello, everyone. So, let's begin. We will be So first things first, look at the title. This is putting a scale to size and math. Let's begin. So the first is the special formula, which is x square is equal to y cube. A more common example of this is 8 square is equal to 4 cube, which both equal 64. Why? So when we look back at our problem, we can say that how can we solve it? Well, there's a simple way. 8 is equal to 4 into 2 whole square. And using the property that x into y whole square is also equal to x square into y square, we can separate 4 into 2 into 4 square into 2 square. Now we can again simplify the 4 square into 2 into 2 whole square. Again using the property, it becomes 2 square into 2 square into 2 square. Simplifying each individual square, it becomes, guess what? 4 into 4 into 4, which is obviously 4 cube. Now, when we come back to this problem, what if we try to do it in a similar way? If we look back at this problem, we can also see that 2 is also the square root of 4. Now, the square root, square of something, is obviously x itself. So, therefore, when we say square root of 4 whole square into square root of 4 whole square into square root of 4 whole square, like over here that we are saying 2 square, like here, the square root and the square cut out and to become, guess what, 4. So if we do this in a similar way, it can become that square root of y into square root of y into square root of y whole square is equal to y cube. So this also suggests that when we break it down, it becomes square root of y whole square into square root of y whole square into square root of y whole square, which is y cube. So square root and square cut out, so it's y into y into y, which is y cube. Have we found out the formula? Yes. So if we notice here, we notice that we need a square root of y, which means y must be a perfect square. What is a perfect square? Basically, x square is equal to something, so that number is a perfect square. So if we apply that to our next perfect square, which is 9 cube, so we must, according to this, 9 cube must be equal to something square. What is the square root of 9? 3. So using this formula that we have here, we can say that this thing becomes 3 into 3 into 3 whole square. Solve it. That becomes 9 into 3 whole square. 9 into 3 is 27 square. When you check that, both does equal 7 to 9. Yeah, so we have proved that 27 square is equal to 9 cube, and it works for any perfect square. Any perfect square cubed is always equal to some other number squared. Next is 3x by 5x. When we try to simplify it, we just kind of cut out the x. So that, what does it leave us with? Guess what? Nothing special. 3 by 5. The reason is that the question is that why do we do that? Now, 3x by 5x can be also simplified as 3 into x by 5 into x. Now, using the property that x by y into w by z is also equal to x into w by y into z, we can do the exact reverse for 3 into x by 5 into x and separate the two. What is the result? 3 by 5 into x by x. Obviously, x by x shall be 1, and 3 by 5 into 1 is 3 by 5 itself. So when we try to do into the original formula 3x by 5x, we just simply, without doing this entire process, we just simply cut x out and 3 by 5. The next problem that we are going to see is a plus b whole into c plus d. So the thing is that what we do normally, we multiply a with c, then again a with d. The reason is why? If we look at here, then we can see that A into C is AC plus AD. Then we pretty much do the same for B into C plus B into D, and the entire formula becomes AC plus AD plus BC plus BD. See this? The thing is that why do we do that? If we look at our original formula, we first need to know the rule that x into whole y plus z is equal to x into y plus z, that is equal to xy plus xz, because x into y plus x into z basically. So if we do that same thing here with a plus b, it is basically like x representing another number. A plus b is representing another number. So if we do that same thing, it will become breaking down c into a plus b plus d into a plus b. Simplify again, that becomes ca plus cb plus da plus db. Now you might notice this answer is a bit different from the original answer. So let's look at that. If we look at our original answer, you may see that it's actually a bit different. Let's explain why. So if you can see from this perspective, original is AC, explained CA, AD, CB, BC, DA, BD, DB. So again we need to know a formula that xy is equal to yx and x plus y plus z is equal to x, y plus x plus z, etc, etc. You can put it in any order, x plus y plus z. So if we look here, AC can also be written as CA, then BD can also be written as DB. Then AD is turned into DA and placed on the other side. BC similarly is turned into CB and placed on the other side. Thus, we can confirm that this is pretty much the same thing that we explained. The next thing is now our scale to size. What is a trillion? Let me get serious here. A trillion. We can represent trillion as, guess what? 1 followed by 12 zeros. 1 0 0 0 0 0 0 0 0 0 0 0 0. That is humongous. In fact, what is it? It is 1,000 times bigger than a billion. So in order to put 1,000 into perspective 1,000 times, if we say 1 to 10, how much is that? 9 digits. Then multiply that by 100. That's 100. Now it's not 9 digits. It's 89 digits. Then again into 10, 1,000, and it becomes plus 899 digits. So that's basically 1 into 1,000. If you look at this pattern, can you see the jump? 9, 89, 899. It jumps multiplicatively, not exponentially though. It jumps multiplicatively, and that number is huge. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 all the way to 89. Then 1 2 3 4 all the way to 899. Now that you've got a perspective of 1,000 times, how much is it actually? How about we now put it into kind of scales? So first things first, what if we say 1 trillion years? So one thing for sure, in 1 trillion years, the Andromeda and our Milky Way galaxy would collide. No, literally, it will be long before trillion years. It will happen 4.5 billion years later. Yeah, you and I are lucky not to be, at that time period, because not only will it be spectacular, some planets or stars might hit Earth, and it will form Milkomedra. Then, how about in 1 trillion years, the sun? Yes, the sun will expand 5 billion years after to become a red giant. It will swallow Earth and move near to the orbit of Jupiter or Saturn. Please correct me if needed. Yeah, if you get the idea, 1 trillion years is a lot. How about a trillion seconds? Like, let's go from years to seconds, little bit less. First, we need to understand that a billion seconds is approximately 31.7 years. 1,000 times that. What is that? 1,000 times that. Guess what? Approximately 31.7 millennia. 1 million, and the plural form of millennium is millennia. 1 millennium is 1,000 years. In other words, 31.7 millennia is 31,680 years approximately. What? 31 years to 31.68 thousand years? That is extremely long. So, what about a trillion microseconds? 1 microsecond is 1,000th of a millisecond, and 1 millisecond is 1,000th of a second. Yeah, you see, 1 microsecond is short, and I mean short. How about a trillion microseconds? Surely it can't be that long. Nope, it's over 1.5 weeks, precisely 1.6 weeks over. $1 trillion bills? How about we take the Statue of Unity, the tallest statue in the entire world, at a staggering height of 182 meters precisely? You would need over a little less than 600,274 statues of Unity for that. And that's a third of the way to the moon. If you know the scale of how far the moon is away from Earth, in the perspective that every single planet, including Pluto, can be lined up within the distance from Earth to the moon, you really know what is that. So yeah, as we know, 1 trillion is the greatest number I have heard so far. Like, in terms of, scaling. That's what this video is about, scale to size and math, which I've already covered. And yeah, that's it. And as usual, thanks for watching the end.